In a previous video presentation I discussed at length the most up-to-date scientific data available concerning the search for Planet X, evaluating many prominent research papers along with their proposed orbits and mass values for the object in question. Invariably, the solutions presented tended to favour an object whose orbital elements were a close match to those of the known celestial bodies within our solar system. A slightly elliptical orbit, though not too extreme, with an orbital plane not too far removed from that of the other major planets. That being said, however, there are certain researchers who differ sharply from this position, who believe that Planet X does in fact possess a highly eccentric orbit about the Sun, and that on the order of every several thousand years it makes a deep penetration into the inner solar system, causing major upheaval to the Earth, as evidenced by our planet's geophysical record. According to the work of Zecharia Sitchin, the main proponent of this theory, the Planet X modern astronomers are today searching for was known to the ancient Sumerians as Nibiru, a planet they identified as a small rocky body with an orbital period of some 3,600 years, the closest approach to the Sun, on par with the asteroid belt, approximately halfway between Mars and Jupiter. Yet others, though, over time have expanded on Sitchin's work, making alternate claims, such that the intruder body is not a small rocky planetoid, but instead a brown dwarf star that is in fact a binary companion to our own Sun. In light of this, it would be very interesting then to consider just what the gravitational effects would be from a significant sized mass body penetrating deep into the inner solar system. Making use of a very sophisticated astronomical program called Astrograv, this current presentation will seek to find out and to reveal if an exotic Planet X, so to speak, is at least within the bounds of possibility. Now, the Astrograv program not only allows one to dynamically model the solar system gravitationally over time, allowing it to naturally unfold, it also allows one to create additional celestial bodies and add them to the known solar system, allowing them to interact with the established bodies. What follows then are three different simulations modelling the deep penetration of a celestial body into the inner solar system, each offering a different mass solution, in line with the major alternative theories for Planet X. The first solution is for a Planet X equal to 4 Earth masses, a value favoured by Zecharia Sitchin himself, who appropriated it from the late Robert Harrington of the US Naval Observatory. The next Planet X scenario involves an intruder body equal to the mass of Mars, which itself is approximately 1/10 the mass of the Earth. The final scenario to consider is the brown dwarf scenario. With this, I model a body equal to 13 Jupiter masses, or 4,134 Earth masses, this being the most conservative estimate for such a body. Now, when using the Astrograv software, I decided to create an orbit for each of the three scenarios which would be identical with respect to all of the primary orbital elements, with the sole exception of mass. The first scenario then to be tested is the 4 Earth mass body, and you can see here on screen the main elements chosen. Now, I have indeed been very generous with the orbit, ensuring that Planet X will in fact not directly travel too close to the other bodies within the system. This has been achieved by setting the orbital inclination at 45 degrees, thus ensuring that the planet will pass underneath the general plane of the solar system as it approaches the Sun. In addition to this, the perihelion point has been set at halfway between Venus and the Earth. This further ensures that the planet will thus pierce through the general orbital plane of the solar system, again without passing too close to any of the inner planets. Now, I have chosen here an orbital period equal to approximately 5,125 years, which I have rounded up to the nearest 1,000 days. This gives a precise value of 1,872,000 days. The semi-major axis of the body is set at just over 297 astronomical units, 3 million miles. You can see then from the initial setup that the Planet X body has been positioned at some 100 astronomical units from the Sun. This is far removed even from the outermost body, which is Pluto, at 40 AU. In passing through the asteroid belt, the most dramatic changes occur to the orbital elements of Planet X. The simulation is brought to an end as Planet X just crosses over the 100 AU mark, thus returning to its initial starting distance. Now, before examining its effect upon the solar system, it would be well to consider just how the primary orbital elements of Planet X itself have been altered due to its interaction with the gravitational fields of the other bodies. Examining its orbital period and semi-major axis, both prior to its entry and following its exit from the solar system, one can definitely see a marked change. The orbit has been dynamically transformed, such that a new orbital period is established almost 2,000 years greater than before. The mean distance from the Sun has also increased by some 72 astronomical units. Now, this is something quite common to many objects which approach our Sun, and one may consider the well-known comet Hale-Bopp. When first observed entering our solar system, the orbital period of the body was established at some 4,206 years. However, due to its interaction with the other celestial bodies, its orbital period was transformed to a new value of 2,380 years. This clearly demonstrates that there is an element of instability when one considers objects in highly eccentric orbits entering into the inner solar system. They tend to be dramatically transformed, attaining entirely new orbits. What though the effect of Planet X at 4 Earth masses upon the other bodies within the solar system? Here one has to note that the time taken for the simulation, for Planet X to go from 100 AU outside the solar system to its perihelion, and then back out again to 100 AU, takes close to 160 years. As a result of this, in addition to running the simulation involving Planet X, I ran the simulation for 160 years from the default file prior to creating the additional body. This represented a control group against which to test the experimental group involving Planet X. Now here I just wish to concentrate on one variable, the orbital period values of the planets, and you can see them in the table as presented. They are the established values of the experimental group following the passage of Planet X into the solar system, its entry and exit back out to the distance of 100 AU. One may note first the orbital period range column. This contains the oscillating elements for each of the planets as they dynamically fluctuate from moment to moment. From observations they are generally found to be within certain thresholds. The average values are given just besides, with the level of displacement also noted. The key question is therefore, do the planets on screen differ significantly from the control group simulation where Planet X was not present? The answer is yes, but for one planet only, the Earth itself. It would appear that the Earth was affected and did suffer a significant gravitational perturbation from the 4 Earth mass intruder body, causing it to extend its orbital period slightly. All of the oscillating elements then as shown on screen are a match to the control group simulation where Planet X was not present, with the sole exception of the Earth. Its value has suffered a slight increase, and one may see this by comparing it to the control group value as separately determined, itself a close match to the sighted sidereal Earth year as given. Overall, one may conclude then that it is possible for a body of 4 Earth masses to perturb the inner planets, provided it gets close enough to affect them with its gravity. Let us now turn then to the second scenario. This is for a Planet X equal to the mass of the planet Mars, which is approximately 1/10 the mass of the Earth. This scenario, therefore, is for an object whose mass is 40 times less than the mass of the Planet X in the first scenario. All of the other orbital elements are identical though. From the initial starting point then, one can see that the simulation unfolds very much in like manner to the first, with the most dramatic changes to Planet X itself occurring as it reaches perihelion. Now, in actually running the simulation here, there is in fact no need for me to present any data as such detailing the effect of the intruder body upon the solar system. I can simply state the result. Upon analysing the data following the passage of Planet X, it would seem that none of the established planets seems to have suffered a significant perturbation or alteration to their orbits, not even the Earth. The gravitational field of Planet X here, at 0.1 Earth masses, was simply too weak to affect a noticeable change to the solar system. Now that being said, if one examines Planet X itself following its interaction with the solar system, one can see almost identical changes have occurred respecting its own orbital elements, as with the first scenario itself. An increase of near to 2,000 years on its orbital period, and an increase of some 72 AU on its semi-major axis. Let us now turn finally to scenario number 3. This involves simulating a brown dwarf star entry into the solar system. Now this type of celestial body is somewhere between a large gas giant and our own Sun. Due to certain physical constraints, it is a star that has failed to ignite to become a bright burning star like our own Sun. Now scientists have established that this type of physical body has a lower mass limit of some 13 Jupiter masses, with an upper limit of some 80 Jupiter masses. In this present simulation, I am being most conservative in choosing a brown dwarf star at its lower limit of only 13 Jupiter masses. Now, as with all other previous simulations, all other values are identical. From the starting position, the simulation begins to unfold very much like the previous ones. Herein, though, I present on screen all of the orbital elements for the major planets, so that one can see them as they dynamically part of the solar system. Major changes are already underway. In crossing the 40 AU mark, the same orbital distance as Pluto, both Neptune and Uranus have already suffered significant perturbations. Their oscillating elements are already noticeably out of bounds. And this, some 20 years before the brown dwarf will reach 1 AU, the same distance from the Sun as the Earth. Now approaching 5 AU, both Saturn and Jupiter have already themselves suffered major disruption. In summarising the effects then, one can see indeed that no planet was left unaffected. The values in orange are the values current to the solar system, with their oscillating elements in blue. The values in green are those established after the passage of the brown dwarf. Now one may note the Earth in particular. No longer possessing 365¼ days, it now has shifted to an orbit of just 350 days. The outer gas giants Uranus and Neptune, including also Pluto, have also suffered, with shifts of several thousand days occurring, and one can see the effects too on Saturn and Jupiter, the inner gas giants. Indeed, both planets began to suffer major disruption some 3 to 4 years before the brown dwarf reached its perihelion, close to being on par with the Earth's own distance from the Sun. Now one can see also the 13 Jupiter mass body itself suffered a significant disruption to its own orbital elements. Not quite as much as with the first two scenarios, but the effect was still significant. Some 1400 years added to its orbital period and some 52 astronomical units added to its semi-major axis. With respect to the brown dwarf scenario here, I can also confirm that I did run the simulation for several more passes, and the result was that the entire solar system was wrecked and the planets scattered. The idea that such a body is a true member of our solar system that passes deep into its interior every several thousand years is simply not possible. Now, in summary of all of the simulations, one has to conclude that there could not be a permanent Planet X body that is a part of our solar system that is possessed of a highly eccentric orbit, as such a body would only be able to achieve a small number of passes before its own orbit was so dramatically altered that it either disconnected entirely from the solar system or was thrown into a new orbit with an established period of hundreds of thousands of years or more in length. If there is a celestial body out there periodically entering the inner solar system to wreak havoc to the Earth,